Imagine a bottle with no inside and no outside, a shape that twists into itself, creating a surface with no boundaries. This is not fantasy, it's the Klein Bottle. First described in 1882, it has fascinated mathematicians, artists, and anyone curious about reality itself. At first glance, it looks like a glass sculpture, but it cannot hold water, and it defies our everyday logic. In this journey, we'll uncover the secrets of this impossible object. From childhood, we assume every object has two sides. A page has a front and back. A coin has heads and tails. Even buildings reflect this, an interior and an exterior. This belief feels so obvious we rarely question it. But mathematics loves to challenge certainty. The Klein Bottle proves that two sides is not always true. It forces us to rethink what a surface really island. The familiar rule breaks down, opening a doorway to strange geometry. In 1882, German mathematician Felix Klein imagined something extraordinary. He pictured a bottle whose neck curves back, passes through its own wall, and merges seamlessly with its base. Unlike a cup or jar, this shape could not separate inside from outside. Instead, it became one continuous surface. Klein's concept launched new ideas in topology, the mathematical study of surfaces and spaces. What looked like a playful thought experiment revealed a universe of geometry beyond intuition. To understand the Klein Bottle, we first meet its cousin, the Möbius strip. Take a paper strip, twist once, and join the ends. The result is a loop with only one side. This strange ribbon shows how geometry can bend logic. The Klein Bottle is like the Möbius strip taken one step further, folded into a bottle shape, twisting into itself completely. What began as a curiosity became a gateway into higher dimensions and new mathematics. Here's the paradox. A true Klein Bottle cannot exist in our three-dimensional world. To complete its form, the neck must pass through the wall without breaking it, a move impossible in real space. What we build in glass is only an approximation, a visual model. The real Klein Bottle belongs in 4 dimensions, where surfaces can pass through each other without collision. This makes it less a physical object and more a window into dimensions beyond our senses. The Klein Bottle is not about volume but about surface. This is the realm of topology, the mathematics of shapes and spaces. Topology asks, what happens when you stretch, twist, or bend an object without tearing it? A coffee mug and a donut are topologically the same because each has one hole. But the Klein Bottle breaks these familiar categories. It has no hole, no inside, no outside. It is a shape that rewrites the rules of classification. Most objects have edges or boundaries. A circle has an outline. A box has corners. But the Klein Bottle flows endlessly without edges. Trace along its surface and you never find a border. It is complete yet boundary-free, like a closed loop of infinity. This property fascinates mathematicians because it challenges how we define space itself. In a Klein Bottle, the idea of limit dissolves. It is a world where edges disappear. Imagine pouring water into a bottle that has no inside. It will spill instantly because there is no container within. The Klein Bottle doesn't separate interior from exterior, it merges them. Inside and outside become the same surface. This paradox makes the Klein Bottle more than a toy of geometry. It becomes a symbol of blurred boundaries, of how opposites can unite. For philosophers and artists, it's a metaphor. For scientists, it's a challenge to visualize dimensions we cannot touch. Glassblowers have crafted Klein Bottles since the early 20th century. They heat, twist, and bend molten glass into the impossible form. But remember, these models cheat. The neck pierces the wall, something the true mathematical Klein Bottle doesn't require. Still, these creations help us glimpse the impossible, a sculpture born of pure mathematics. When you hold one, you're touching a riddle, a shape that should not exist, yet somehow stands before you. Over time, the Klein Bottle escaped mathematics and entered culture. Artists use it as a symbol of paradox. Writers weave it into science fiction. Sculptors showcase its alien beauty in galleries. Even puzzle makers build toys inspired by its form. Wherever it appears, it sparks wonder and confusion. To see a Klein Bottle is to question what's possible. It carries a message. The world is stranger and more fascinating than it first appears. Beyond science, the Klein Bottle symbolizes unity of opposites. Inside becomes outside. Beginning connects with end, dualities dissolve into one. Some see it as a metaphor for consciousness, or for the mysteries of the universe itself. Like the yin and yang, it represents harmony, hidden inside contradiction. While mathematics gives it form, human imagination gives it meaning. It's both abstract object and poetic idea, bridging logic and wonder. The true Klein Bottle lives in 4 dimensions. In 3D, we can only approximate it. But in 4D, its surface flows perfectly without self-intersection. This makes it a rare bridge between what we can build and what we can only imagine. It reminds us that our senses are limited, we see only 3 dimensions, but mathematics opens doors to more. The Klein Bottle is a keyhole, offering a tiny glimpse into higher realities. Teachers often use the Klein Bottle to spark curiosity. It shows students that math is not just numbers, but imagination. It demonstrates that space and form are not fixed, but can bend in surprising ways. For learners, it's a gateway proof that the universe is far stranger than the textbooks suggest. The Klein Bottle doesn't just teach math. It teaches humility, reminding us that the simplest assumptions can be overturned. The Klein Bottle belongs to a family of impossible shapes. The Möbius strip, the Penrose triangle, the Escher staircase all challenge our sense of space. Each offers a puzzle, a glimpse into alternate logic. But the Klein Bottle stands apart. It is not just illusion, it's a real mathematical object. Unlike drawings that trick the eye, it exists in higher dimensions with full consistency. It reminds us that some impossibilities are not tricks, but truths waiting to be discovered. Some physicists use the Klein Bottle as a metaphor in cosmology. It resembles certain models of space-time where boundaries fold and merge. In theoretical physics, the universe itself could have properties echoing the Klein Bottle: closed, infinite, boundary-free. While speculative, these ideas show how mathematics and physics often intersect, shaping our imagination of the cosmos. The Klein Bottle whispers of universes that curve back on themselves, where inside and outside may be one and the same. Over 140 years after Felix Klein's discovery, the bottle that shouldn't exist continues to inspire. It fuels art, education, physics, and philosophy. But more than that, it inspires curiosity. It proves that even the most ordinary assumptions, like the idea of 2 sides, can be shattered. The Klein Bottle is a riddle in glass, a reminder that reality is not always what it seems. And in a world hungry for wonder, that might be its greatest gift. The Klein Bottle is more than mathematics. It is a story about curiosity, imagination, and the courage to question. From Felix Klein's vision in 1882 to modern classrooms, from glass workshops to cosmic theories, it continues to remind us that the universe is stranger than we think. It has no inside, no outside, and no boundaries. It defies the rules we take for granted. And yet, it exists, if not in our 3-dimensional hands, then in the higher dimensions of thought. The Klein Bottle teaches us that sometimes the impossible is real, and that wonder itself is a kind of truth. If you enjoy this journey into the impossible, remember to subscribe for more mysteries of science and space. Share this with a friend who loves a good puzzle. And don't forget to watch our next exploration into another shape that bends the rules of reality. Until then, keep questioning, keep imagining, and never stop exploring.